So this last example has us use implicit differentiation. Here's our function. So the first derivative, nothing changes, just as usual. Take the derivative of x squared, that's 2x. Take the derivative of y squared, that's 2y times dy by dx, because we took the derivative of a y. And that equals the derivative of 25, which is 0. Now, as usual, we need to get the dy by dx by itself. So start off, we'll move the 2x, divide by 2y, and simplify. So there we have the first derivative, negative x over y. To get the second derivative, we take the derivative of this. It is a quotient rule, so we have f, we have g. F prime, derivative of negative x is negative 1. G prime, derivative of y is 1 times dy by dx, or just dy by dx. So then the second derivative, d squared y by dx squared, quotient rule, f prime g minus g prime f over g squared, so f prime g minus g prime f all over g squared. Now there's a little bit of simplifying we can do right off the bat. Negative 1 times y is negative y. And that term at the end, negative and negative x, will make plus. And it's just customary to put the x before the dy over dx. But now we have a slight issue. Now we have dy over dx inside the second derivative. We're not allowed to have that. But we're lucky that just up here, we figured out what dy by dx was. It's negative x over y. So I'm going to take that and I'm going to substitute it in. And a little bit of simplifying that we can do with that. However, this leads us to another bit of a tricky bit. We have this fraction x squared over y inside of another fraction, this large fraction. We need to get rid of it. So what we can do, instead of saying divide by y squared on the bottom here, in this case it's a nicer way of putting it. Instead of saying divide by y squared, we can multiply by 1 over y squared. We're dividing with fractions, so we flip and multiply. Now what we need to do is take that 1 over y squared and distribute into both those terms in the front bracket. Like so. And one tiny last bit of simplifying this first term. We have a y on the top, y's on the bottom. And there we have the second derivative.